All right, I think we're on.
No scrubs? I had my glasses on. And I did all this.
Yeah.
I thought it was Betty. And I was
So
like,
I'm sorry that we didn't have class yesterday because it was molding. Okay. How was the Mars thing? The Mars thing. Did anybody go? Learn about Mars chemistry? I heard there was food.
I lived 2 hours away. I'm not.
I take that away. I just wondered if anybody had gone. I haven't heard anything. Okay, here you go.
I don't even know that
Should have watched it already.
word. Did you hear her? Did she shout at you out yesterday? Yeah, I've been told her on Monday. Sorry.
Yeah, I guess it was, yeah, Monday.
Yeah, I was.
Where are the chiral centers in the molecule below? So you're going to type the numbers. I've made every carbon a number into your clicker in numerical order with no spaces between them, and then hit the OK button. I guess it's better than nothing, Kate.
I know, I'm just going to put in some numbers.
But there's a lot of possibilities. Not just 4. Hurry, hurry. Hurry, hurry.
Well, I don't know the answer, so I'm gonna go with 8.
I don't have that. I put 5 and 6.
All right, so there's 1, 2, 3. I'm getting 23. Is that right?
I don't know what.
I got 23 twice. All right, you're gonna have to make a guess. You'll be begging for these by the end. Put this on the top.
Yeah.
All right.
If you don't know, make a guess and we'll go over it.
Because most people just like don't show up and like never give them a time that they're gonna take it. So it's just take them. I give them a time. I just don't want to do it.
Okay, I got 2 more, so make a guess because I'm going to hit the button. You guess? Okay. Caitlin guessed. She said everyone should have guessed. Okay, look at all my choices.
Somebody got my answer, yay.
They did? Cool. Okay. How do you know if it's chiral?
I just like those numbers.
How do you know if it's chiral? 4 different groups attached. Okay, so if you look at carbon 8, is there 4 different groups attached to it? No. What's attached to it? 3 hydrogens. Those are 3 the same. You don't even have to go to the next one. Okay, what about 7? Okay, well, we have a methyl. We have this side of the ring, and we have that side of the ring. And you see the 2 sides are different? Okay, what else is on that carbon? A hydrogen. So 7 is one of them. Okay, what about 6? It's bonded 2 times to number 5, right? So 6 is out. What about 5? Same reason, out. Okay, what about 4? No, has 3 hydrogens. What about 3? Okay, 3, we have the methyl, we have the 2 sides of the ring, and we have a hydrogen. So 3 is also chiral. What about 2? Yes, it's symmetrical. As you go around the ring, do you see that it's the same? You have to go around the ring. It's got to be different. 2 is not chiral. Okay, it's got to be asymmetrical. What about 1? No. Okay, so it's, oh, not going to do that unless I change. There we go. It's 3 and 7. Hmm? Are we getting it? You got to look for 4 different groups. You got to look at the whole thing. Okay. Okay. Determine if the following are R or S. Okay. So we're going to do like 5 of them. All right. So hopefully by the end you will be able to do it. All right. So where do we start? Where do we start? What's the first thing you do? Okay, here's the chiral center, right? Okay, and so we're going to look at the atoms that are directly attached to this carbon, which are, we're going to write them down. C, no. We're doing it. C, and A, B, R. Does everybody agree that those are the 4 atoms directly attached to that chiral center? Okay. Everybody agree that that is a chiral center? Okay, just checking. Okay, so what can you determine at this point? BR is 1. Okay, so this one is 1. Okay, now what do we do? They're all the same. They all have C's. So what you have to do, you took 1 step. Okay, so if I'm standing on this C right here, I have 3 steps that I can go. I can go to an H or 2 C's. You see how I got that? Okay, what about this C down here? Where can I go? I'm standing on the C. I'm going to step around the molecule. It's like a video game. So there's 3 H's. Those are the 3 steps I can take. So you're going to have an H, an H, and an H. When you start, you always have 1 atom. Okay? If you have carbons, then, which is most of what organic molecules are, after that you'll have 3 possibilities every time. Okay? All right, what about this one up here? We're here on this carbon. So what are going to be my steps? Where can I go now? I can go to a C or an H or an H, right? Now, do we have points of difference? Do we have points? Yes. Does everybody see that they're not identical anymore? Okay. If it's a chiral center, there should come a point where they are not the same. Okay, and remember that you will step out from your chiral center until you get to the first point of difference. Okay, all right, so what do you think now? Who can you tell me anything for, can you tell me who's 4? The methyl's 4. Okay, because they're all H's, so they all lose. They're all going to lose to a carbon on the other ones. Okay, how about the other 2? Who is going to be 2, excuse me, and who's going to be 3? Which one? The top one is going to be 2? Why? Yeah, but don't we have a carbon on both of them? Let me get a color. Oh my gosh, give me a color. Okay, do you see that? These are the same. Okay, so the difference is going to be an H and a C. All right, so who's going to be 2? It's hard to write them in order. Sometimes what I try to do is I try to write from high priority to low priority. But because you can draw that molecule, okay, here's the top one. You can draw that a number of ways. So, yeah, you have to look for what's the same and what's different. Okay, so what we're going to end up comparing between these two is going to be the C and the H. You look at this one up here, that little isopropyl. That's why I gave each one of these one slide. Okay, this is the carbon that's attached to the chiral center. Now look what we've got, an H, a C, and a C. Okay, so who is going to be 2? The one that has the carbon on it. That's 2. Okay, and who is going to be 3? The one that's up here. Okay. All right, so we're going to make one red. Okay, so that I can use my model with you. Okay, now that's only the beginning, okay, the first part. Now what do you have to do? You have to rotate it so the group that's number 4 is away from you, okay? And then look at the other 3. Do they go clockwise or counterclockwise? It's absolute configuration. All right, so I'm going to have my red and my green in the plane. My white one is coming out, and my purple one is going back. Does everybody see that part? Okay, now I grab which one? The white one, because that's number 4. Okay, and I turn it. It doesn't matter if you turn it, okay? It's going to be the same. All right, some people get hung up on that. All right, so I've got it like this. So what was 1? Red. Okay, so that was 1. And purple was 2. Okay, and the green one was 3. Okay, back here in my hand is number 4. This is what I'm holding in my hand. Okay, so which way are we going? Clockwise or counterclockwise? The 4 is being ignored. All you look at is 1, 2, 3. 1, 2, 3. We're going clockwise. So it is, it better be R, right?
How does that work with this? Why is this going the other way in the drawing? Why is it going the other way?
Because up here, the molecule is oriented differently. The way RNS works is that every molecule is going to be oriented like this, where you're going to have 1, 2, 3 or 1, 2, 3, but number 4 is in your hand like a bouquet. Okay, and you are looking at it. Okay, you look straight on at the chiral center. All you need is something with 4 different colors. Okay. All right, how we doing? All right, well, let's do the next one. How about this one?
We get the colored marshmallow.
Yeah, you can get the color. Now, the trick is you got to make it a tetrahedral. Okay, don't make it, I don't know, whatever. If you don't make it a tetrahedral, then when you rotate it, it'll be goofy. All right, so does everybody find the chiral center? Are we good at that now? Maybe? Okay, so here's my chiral center. I'm going to take my step out. Okay, I'm taking one step out and I get an H. What do I get up here? A carbon. What do I get down here? A carbon. And what do I get over here? A carbon. Okay, so what do we know right now? The H is 4. Do y'all agree with that? That the H is 4? I'm gonna try to make that skinnier and see. The H is 4. Okay, now you look at your carbons. Okay, so if we look at this carbon, this is where we're standing right now. What's attached to that carbon? A carbon and 2 hydrogens. Okay, so, and I'll tell you what, I'll draw them in high to low. Okay, CHH. Okay, what happens on this carbon? Here, I'm over here. Okay, what are my next 3 steps? I could take an H, or a carbon. So that's CHH. Okay, now what do we do up at the top? Okay, at the top we have a multiple bond. If you take a step from here, do you see the only options are going to be a C and an H? There's only 2 steps. So to compare correctly, they do the swap and fill in. Okay, so watch what I'm going to do. Here is my double bond. Okay, this is where it's attached to the chiral center. Okay, what are the atoms that are in the double bond? There are 2 what? Carbons. Okay, so you could have a carbon and an oxygen. You could have a carbon and a sulfur. You could have a carbon and a nitrogen. Okay, so what we're going to do is we're going to swap. In this case, they're the same, and we're going to fill it in. So we're going to put a carbon here and a carbon here. Because now, when we look at this carbon, I've got 3 possible steps. C, C, H. That's how you figure out what to do with multiple bonds. What if it was a triple bond? What do you think you would do? You would fill in 2 times. Okay? And I can draw some out, just some multiple bonds, so you can see how to do it a little better. All right, so now can you tell me anything about priorities? Who's got a winning atom? The double bond one does, right? Okay, so here's this C is going to be both of these H's down here. Okay, so that's going to make this number 1. Okay, now what about the other 2? They're still the same. So what you have to do is take another step. Okay, so which path do you go? Well, if I decide I want to go this path, what would happen if I took another step? I'd fall off the end of the molecule. Okay, so obviously I'm going to have to go this way and go through the carbons. Okay, so when I go through the carbon, okay, I'm up here now. Okay, so what's attached to this? 3 what? H's. So we went to the carbon from the chiral center. We went to the next carbon, and now we look at our possibilities. H, H, H. Okay, that's what I'm doing.
Is there not a C on there? Is there another carbon attached to that?
No, this is that carbon. No, because you already were there. You keep going forward. Keep going forward. Maybe that's what will get you. All right, so now what about this carbon? I'm going to take a step from here. So I'm going to be on this carbon up here. So what are my choices going to be? C, H, and H. Okay, now do we have a point of difference? We have a C and an H that are different. Okay, so who wins? Who's going to be number 2? Right, which is this group is going to be 2. So what does that make that other group that's left? 3. Okay, so you just keep taking a step out, okay? And you're looking for a point of difference. There's only going to be one atom at the beginning, and then after that, you'll end up having 3 atoms to pick from every time, okay, that it's carbon. Okay, so now what do we got to do? Well, we got to take this and I got to put it in that orientation. So where's red going? Red is going back, and green and purple are in the plane of the board. And white is coming out. White is 4. Okay, so here's my green and purple in the plane. Here's my 4 coming out, and what is this? That's my 1 going back. So I'm going to grab which one? Number 4, and I'm going to put it away from me. Okay, so what do we have? We have, this is what it looks like after you do that little rotation thing. Okay, does everybody see how I got that from this? Okay, they're coming out a little bit. All right, so this was 1. What was the purple was 2, and the green was 3. Which way are they going? Clockwise or counterclockwise? So this one should be S. So there's 2 steps. Step 1 is to give each group in the chiral center its priority. And then step 2 is to orient it correctly by rotating it so number 4 is away from you. And then looking at where the last ones are. Okay? Okay, it's a spatial thing. I mean, once you get the priority thing worked out, it's a spatial thing. Okay? What's the next one? This one. Let's do that one. It's got a triple bond in it. It'll be good to do the triple bond. Okay? Now, do you remember what that is? What kind of picture is that? That's a Fischer projection. What does that mean? It's real important that you know what that means. There's a carbon in the middle. What can you tell me about the H and the OH? How are they going? They're going out towards you. Okay, what are the ethyl and the triple bond thing? Where are they going? Back. Okay, notice that nothing's in the plane, even though we have straight lines. Okay, it's a Fischer projection. Okay, so now let's look at our 4 groups. We're going to have an H, a C, an O, and a C. Okay, what can you tell me right now? There's differences. So who's number 1? Oxygen is number 1. Okay, so that's going to be 1. What else can you tell me? Hydrogen is number 4. Now all we have to worry about is who's 2 and who's 3. Okay, so if we go from here, what is our next step? Possibility. Right. Okay, but if we go from here, you notice there's just 1, it's a C. So we do this swap and fill in thing. It's just a means to get you enough atoms to compare. That's all it is. Not like we're changing the molecule. Okay, so I have triple bond, so, and it's 2 carbons. So what I'm going to do is I'm going to do it once, twice. Remember that a triple bond is 2 pi bonds and 1 sigma bond. All right, so what am I going to have now here? C, C, and C.
I'm really confused about what you're saying, like filling it in twice.
Okay, when we had this, when we had that was our group. When we go from the C, we would just have a C and an H. We wouldn't have enough atoms to compare. You have to have the same number. You have to have 3. So what we're going to do is fill in the double bond. It's like you're filling it in. So what we did was we did this, and we put a C here and a C there.
So you're saying though that you're filling this triple bond in twice, but you put 2 new atoms in that one. So did you fill that one in twice also?
No, I filled this one in once. The double bond I filled in one time.
You added 2 new atoms though.
Right.
Each double bond.
Each double bond is filling it in one time. Here, I added these 2 carbons for one of the double bonds and these 2 carbons for the other double bond.
So you're just taking one of the bonds and making 2 carbons out of it.
So that you have the same number of atoms to compare. Otherwise, all you'd have would be a C. Okay, and so the problem is who wins, because that's the same. You have to have a point of difference. So to make up for the fact that there are multiple bonds, we fill them in with the atoms that they're attached to. Okay, so this is, let me get another color. This is a carbon and a carbon. So we swap it and fill it in, because we're going to do some that are like not to another carbon. Okay, so we're going to fill it in with another element other than carbon. Okay, so now I'm at this spot and I want to decide what's the point of difference. You can see there's a triple bond there. We've got 1, 2, 3. So now we have 3 carbons to compare up there. Okay, does the triple bond always win? Are you thinking right now, oh, the triple bond's always going to win? No, it's not always going to win. It's important that you compare the atomic numbers of the elements. Okay, so here, these are the same. So what I'm going to compare is going to be that C and an H. Okay, so who is going to be number 2? The triple bond is. Okay, the only thing about this is this filling in thing is just to give you the same number of atoms to compare. That's all it is. Okay, don't try not to get hung up on it. Okay, so this is a 2. Okay, and then 3 is the top one. Okay. Okay, it didn't stop, did it? Okay, now you have to orient this so that it matches that. So that means that the red and the white have to be coming out. And the green and the purple have to be going back, because that's what that Fischer projection is. Okay, so get your thing oriented. There's nothing, no bonds are in the plane. The carbon is the only thing in the plane. Okay, and now which one do I grab? Number 4, and I'm going to pull it away from me. Okay, so I'm going to have, here's the green one, and that was 3. I'm trying to use the same color for the same number every time. Okay, so what is this one now? 1, 2, 3. That's counterclockwise, right? So it should be S. We starting to get it? Okay, So you've got to practice it, because that's the only way that you will get it in your brain, is to practice it. Can you mix up the priorities? Yeah. And still get RRS correct? Yeah. So guess what you'll have to do on the test? You'll have to show me those things. You're going to have to show me your priorities. You're going to have to show me your rotations and tell me if it's RRS. You can get the priorities screwed up the orientation, and get it right because you got RNS backwards. Okay? Like, truly, there's only so many possibilities. So that's why you're going to have to show me your work. Okay? So try to do it. And if you want to bring something like this to the test, you're welcome to bring it. I'll let you do it for this test. But in the future, you won't be able to do that. Okay? When you go take the MCAT, they're not going to let you bring a little molecule in. When you take the PCAT, they're not going to let you bring in a tetrahedron. Okay? So what I recommend you do as you study is you try to do it in your mind, the rotation, and think spatially. And this will also help to train your brain. Okay? Because, I mean, you got to know what's behind that heart. Okay? You can't, and where it's located. You've got to think spatially, even though you can't see it. Okay? You're going to have to know. That's why you do all that anatomy and all that stuff, right? So you learn that stuff. But you think they're going to let you bring a model of the heart and everything into the, you know. Sorry. All right, now look at this one. Okay. Everybody find the chiral center. Are we good at that now? All right, I'm hopeful. Okay, so now as you go out from this chiral center, what are the atoms? What are the 4 atoms that you're going to compare first? I got a carbon up here. I got a carbon down here. I've got an and a chlorine. Okay. So, what do you know already? H is 4. Poor hydrogen, he gets the shaft all the time. Okay, H is 4. Okay, I've been using red for 1. Chlorine is 1. All right. Now I have 2 carbons. So I'm going to take my little steps again. Okay, so on the bottom one, I'm right here. I'm on this carbon. What are my possibilities? An H, and another C. Okay, so you see how I got those 3 atoms? All right, now look at the top one. What do you want to do? It's a double bond. I'm standing right here. Well, you know there's an... Ooh. Go away. Go away. Okay, go away. You know there's an A. And you know there's a Z over there. Okay? All right, but wait a minute. See how there's not enough atoms to compare. Okay, so what you'll do, here's this piece of the ring. Okay, so what we're going to do is we're going to put an extra C on each of those. All right, so we're going to have C, C, and H. Okay. All right, so what are we going to compare? We're going to compare the C versus the H. The C versus the H. Okay, so which one is going to be number 2? The C, the top. So this is going to be 2, and the bottom part of the ring down here is going to be 3. It's okay that they're holding hands back here. Okay, we're not going to let that mess us up. Okay, now you know the priorities. So what you have to do is put this in that same orientation. So the purple and the green have to be in the plane. And the red is going back, and the hydrogen, the white one, is coming out. Okay? It's okay that they're holding hands back here. Okay? So I've got the white one, the hydrogen coming out. I've got the chlorine going back, and I've got the green and the purple are in the plane. So now which one do I grab? The white one, and I pull it away. Okay? This is what it's like now. So I've got my green, which was 3. My purple, which was 2, and my red, which was 1. Which way am I going? Clockwise or counterclockwise? Clockwise. Okay, so this is R. If I drew the mirror image, what would it be? RS. F. It's always the opposite, okay? Yeah, it was not a trick question. It just sounded like a trick question. All right, how about this one? You don't have that one? Well, just write it down. Kind of similar to that other one we did. Okay, so the first atom that I'm coming out with is going to be an H. I'm going to try to go over here. A C, an O, and a C. Agree? All right. So what can you tell me right now? Hydrogen is 4. And OH is 1. Woohoo! Okay, we only got 2 to decide now. All right, so do you remember what the structure of CO2H is? Okay. I'm going to go down here so I don't get by that thing. That's what CO2H is. Okay, it's what functional group? Carboxylic acid. Very good. Okay. All right, now I'm standing on this C right here, and do you see that I only have 2 atoms? Okay, so what do you think we're going to do? We're going to fill it in. Okay, so to fill it in this time, I'm going to swap it and fill. So down here, I'll put in O, and on the O, I'll put a C. That's why I keep saying swap and fill. Okay, so if I was here, now my choices are going to be O, O, O. Oh. See how I got 3 choices? Okay, what about the triple bond? Here was the triple bond. Okay, I've only got a C. So what will I do? I will fill it in. C, 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 C. Okay, so here's where I am. Now I'm going to have C, C, C. See? Okay, so who is number 2? The top one. Why? Because O beats C. Okay, so this one is 2. Worried I'm going to mess up the recording. All right, so that means that the triple bond is 3. Last time the triple bond was 2, wasn't it? It depends on what you are comparing. Okay. Okay, now what do we got to do? We've got to have our red and our white, our red and our hydrogen coming out. Our purple is at the top and our green is at the bottom, and that's going back. Okay, so I'm going to grab the hydrogen and I'm going to pull it away from me. Okay, so what do I have now? A hot mess. Okay, there's 3. Okay, my red one was over here. That's 1, and purple was 2. He should have been 1. What do I get? Which way are they going? Clockwise or counterclockwise? Clockwise. So it's R.
Is there any other way to like understand that orientation of that, like how you put that?
You mean what the plus means or the rotating?
Like the rotate, like when
The
you're-
rotating you have to practice.
There's no.
Think about, do you notice that the hydrogen and the OH are coming out? So I'm grabbing the OH and I'm pulling it back. Where does the hydrogen go? Or the OH go? It flips to the other side. Because the tendency is to go 1, 2, 3, it's S. But you can't. You have to get that H back, the number 4 group back. So when you pull it back, remember, they're all attached. So the OH moves over. Okay, and that's how come it's over here. 1, 2, 3. And so it really just takes practice. And you'll get like better at it, like real fast. Just start doing them and start working them out. Okay, and it will make a difference. Okay. If you're doing them and you're really stuck, like you're getting them opposite every time, just come to the office and I'll see if I can figure out what you're doing. Okay. Usually when people are getting them backwards, they're not putting whatever they're using to help them see the space in the correct orientation. It's got to match that. Whatever you start with, it's got to match. So you got to be real careful about that. So you have to have the H and the OH, the red and the white one going out, and the purple and the green are going back. You have to be in the same orientation as what that molecule is. And then grab the white one and pull it away. Okay, and then grab the white one and pull it away. Okay, okay. Oh, that's not what I want to do. I want to do this. No, we're not going to do that yet. I'm scared to let you do that yet. All right, so what we're going to do is we're just going to look at the multiple bonds. Okay? Okay, so here is okay, this is where it would be attached to something, Chiral Center or something, okay? So how do you consider that when you get to here and you have to go to the next step? So what you do is this is going to be equivalent to what will be up here, a C and a C. Okay, so if I'm here, then the next step will be C, C, or H. Okay, what if it's this? Okay, what functional group is that? Aldehyde. Okay, so this will be equivalent to, this is what you use to do the priorities. Here I'll put in, and here I'll put a C, because it's a C double bond O. Swap and fill, swap and fill. We're just filling in those pi bonds with single bonds. Okay, just to give enough atoms to compare. That's the only reason. Okay, all right, what if we had this. What would that be equivalent to compare? If you're standing here, what are you going to have? And so here I'll put, here I'll put, here I'll put, and here I'll put C. You very rarely ever go to those. So you'd have N, N, N. Any better?
That's never gonna change though, right? So like the triple bond is always gonna be attached to that one no matter what. So what's the point of that step of the triple bond? Like it's always gonna be a C to an N or an N or an N.
Right. But you have 3 atoms, okay? Because what if you have, all right, I will give you these 2, and I want you to tell me which is higher priority. There's only going to be 2 of them. It's not going to, oops, priority. I can spell on Wednesday. Okay, so what if I had this group and this group? Right. So this is what you'll be considering. So here's the C. That's the first. Okay. So you will have 3 N's for this one. Does everybody see that? Okay. Here I had a C, and I'll have an N and 2 H's. So what am I comparing? I'm comparing what's different. So what's different is going to be an N and an H. So which one would be higher priority? The triple bond. You need enough atoms to do that. Okay? Okay, we got 2 minutes. I mean, what you need, Guanisha?
Okay, so if you have like C and N and then C, H in, like does it matter the order?
No. No, it doesn't matter. I try to write them in order of highest atomic number to lowest. Right, you're just looking for what's different. Yeah. So if you wrote this one HHN, I mean, obviously those 2 are the same. Doesn't matter. Okay, so here, I'm going to give you another one. Okay, what if you had so we've got a C and we've got a C. Okay, what is going to be our next step over here on the left? 2 O's and a C. Everybody agree? What is my choice on the right? It's going to be a chlorine and 2 H's. How many points of difference do I have? Well, I have 2. Yeah, oh, no, I have 3, don't I? Okay. Do you see that it's going to matter which one you pick? Because if this guy picks hydrogen, he's automatically going to lose. So this is where you pick your biggest gun. Okay. So you're going to pick the O versus the chlorine. Okay. So who is higher? Chlorine, because its atomic number is, yeah. And feel free to look at the periodic table during the test. Okay, so this one is going to win and be higher, even though this one has a double bond in it, okay, and oxygens. Okay, so practice this. You saw there's going to be a molecule. First question. Okay, so practice, and if you have this, something, bring it. You might have to share your gumdrops and jujubes or whatever they're called.
Oh, yeah. Everybody was out of there by quarter. Because I didn't look at, I just grabbed it and left. Why are you so
Yeah.
You said he's gonna.
take you out?
Move that one to the front of the semester for future classes.